Hello there. Today we are going to see the series of videos in machine learning. Today we are going to see about confusion matrix. Before we go to the confusion matrix, let's check out some difference. Introduction for confusion matrix. We have got a classifier example which classified our mail to a regular mail and to a spam mail. Correct? This is one differences. So we have got inbox and we have got a spam mail. But classify that. But before we fed to it, for an example, this is my classifier had done an inbox and this is spam mail. But it also classify a spam mail in my inbox. Our algorithm wrongly classifies some values before we put the model into it, what mistake it has done it. So if we do a classification algorithm, so what are the errors it's going to do before we fed to it. So if our classifier is getting 80% result, fine, we will improve our classifier 90%. So for that result 92%, that means accuracy. So if our classifier is doing a very good classification, then we can put this one to a model. So we have got an input, we have a classifier, and multiple output labels categories are given. Then there is a error measure. What is the error measure? Classifier model has multiple output. Most error will tell us the total error. So if we have more error, that is 80%, then our accuracy is not good. If it is 92%, we said our accuracy is very good. Let's fed to the model. During classification, we have to overcome the limitation of accuracy. If there is a significant class imbalance, then we have to go for an example, this is my classifier and this is my mail, which is email, and in that email I have got a regular mail, that is regular mail, and spam mail. So here we have got inbox and we have got spam mail. This should be go there and this should come here. So our model has done 8 out of 10. That is my accuracy is 80%. I need to increase my accuracy to 90 to 91%. Then only I can fed this one to this one. That is what how to measure the error, what is an accuracy, and all those things before feeding it to the algorithms. Then this is called a confusion. That part comes into accuracy, and we will be seeing that imbalanced data later on in our videos. Correct? Now coming to this one, confusion matrix. I have got a 2 by 2 matrix which is in this form. This is my actual and this is my prediction. No, no, yes, yes. There is true negative, false positive, false negative, true positive. Correct? There is true negative, true positive, false negative, false positive. True negative, model has predicted no, model has predicted no, and the real value is also no. The model has predicted no, the real value is no. Let me change the color for it. Correct? True positive, the model has predicted, the model has predicted yes, my actual value is also yes. False negative, my model has predicted false negative, model has predicted yes, my actual value is not. The model has predicted yes, my actual value, and this is one also called as type 1 error. Do remember what is type 1 error? It's false negative. What is type 2? This we call it as type 2 error, and this is called as false positive. So false positive is type 2 error, false negative is type 1 error. What is false negative? Actual is no, predicted yes. What is false positive? Actual is yes, predicted is no. Actual is yes and predicted is no, and this is called type 2 error. This is a confusion matrix. So we will solve the problem. Now let's take an example. This is my what do you call confusion matrix. This is my confusion. That is, this is true negative, false negative, false positive, true positive. See here n, and this is no. So this becomes n, true, false, true negative, false negative. This is S. S means positive, positive. Correct? Positive, positive. This is true, false, true, false, false, true. Correct? This is the formula. How do you remember it? Again, remember, this is actual, this is prediction, no, no, yes, yes. So no means N, true, false. S means P, P. What is true, false? Opposite, false, true. Coming up. This is true, false, false, negative. Correct? What is coming here? It goes down. This is my confusion matrix. And let's take an example. I have got this values. Correct? My true negative is 50. My false negative is 5. True false positive is 10. True positive is 100. Total is predicted no is 60. Predicted yes is 105. Actual no is 55. Actual yes is 110. Total is 165. Total is 165. So let's move on to this one. What is accuracy? Total by T, T, positive, negative. Accuracy is total. True positive, true negative. In order the terms is just remember T, T, positive, negative. So accuracy is T, T by total, positive, negative. So it's 100 by 50. What is true positive? 100 by 50. 100 plus 50, sorry, 100 by 50 by 165, it is 0.91, sorry. So my accuracy is 0.91, that's very good. Correct. Error is, I am getting an error 0.001, 1 minus accuracy. And total is given by TN, TP, that is 165, we got it, correct. And my error is 0.h, very good, correct. This is very, so we found out what is accuracy. Now misclassification rate. What is misclassification? Type 1 error plus type 2 error by total. Type 1 error is F1, 5 plus 10. 5 plus 10 by 165, that is misclassification. There is a misclassification error, that is 0.009. Then comes a recall or sensitive. Recall or sensitive and precious. Recall or sensitive and precision. These two formulas are very important. Do remember recall and precision. Top is same. Top is same. True positive, true positive. Actual yes by predicted S. What is actual S here? What is my actual S? What is my actual S? 110. So it is 110. True positive 100 by 110. This is mine. And precious true positive, that is 100. Predicted yes. What is my predicted S? This is predicted S. Altogether 105. It should be 105. Yes, 105. And I got it 0.95. Correct. This is what recall. Now let's come to F1 score. F1 score is divided by 2 divided by 1 by P plus 1 by R. 1 P is precious, R is recall, that is 2 into P into R by P plus R. And how do you got it? And we have seen somewhere down the line why we use this imbalance. Let me tell you, this is my imbalance. Why F1 score is used. Now for an example, there is an imbalance data. One data is having 90%, other data is having 10%. So this is, one is 10, another one is 20, 10, 90 and 10. That is very imbalanced data. One is having 90 records, another is having 10. Fine. If the imbalance is 50-50 or then it is not good also. But here we have got 90-10. So in order to do that one, we multiply and divide your precision and recall by 2 in order to get your F1 score. So in that situation, what happens is that if there is an imbalanced data, we cannot able to go for accuracy, which is this accuracy not correct. What is this one? This accuracy, we will not able to do it. Accuracy properly. So in order to do that one, what we have to come down with F1 score. What is called a recall precision, and it is a harmonic of recall and precision. What do you mean by harmonic mean? Let's see. I have got 5 data set. 1, 2, 3, 4, 5. Correct. Harmonic means total value by reciprocal of the observed value. What is the observed value? 5. What is the reciprocal of 1? 1 by 1. What is the reciprocal of 1? 1 by 2. What is the reciprocal of 3? 1 by 3. What is the reciprocal of 4? 1 by 4. What is the reciprocal of 5? 1 by 4. So if I have got this one, 2 by 1 by 2 by reciprocal of precious and recall. If I do all the calculation, I get this one. So F1 score is nothing but 2 by harmonic mean or 1 by harmonic mean of precious or plus a recall. So I got this one. Now in the above example, I have got precious, I have got recall. So my value is 0.9091. So my F1 score is 91%. It's not bad, correct? So it's 2 into 4. What is P? We have got what we P 0.90, P is 0.95. So I have put it 0.95 and R is 0.90. I have put 90. Correct? So this is my F1 score. Now let's take an example. We have a given data. What is that label? 1, 2, 3, 4. True label. This is the data. Predicted value is this one, and this is the memory location for it. 1, 2. True positive. The classes where the actual 1 positive and the model predict 1. This one and model predict 1. 0, 2 and 5, 8. 0, 2, 5, 8. So I have got 4. True negative, there are classes where actual 0 negative, but the model predicted 0. So both are 0. That is 1, 4, 7, 9. 1, 4, 7, 9. I have got 2. False positive, these are the cases where label is 0, but model is predicted 1. Label is 0, but model predicted 1. Label is 0, that is 6. Label is 0, product predicted 1, that is F1. And false negative, this is the case where actual label positive, but the model predicted 1. So actual label 1, the model predicted 1, that is 3. Label 1, 3. So I've got 1. Now I put this in my confusion matrix Tn, Fn, Ft, Pp. That is true negative, true positive, false negative, and that is 4, 1, 1, 1. Accuracy is this one, and my error rate is this one, precious is this one, recall is this one, F1 is this one. Is it good? I'm getting accuracy 80%, my error rate is 20%, my precious is this one, my recall is this one, my accuracy, if there is imbalance, but still I'm getting 80% result. I hope you got it. Let me check it out for my, what do you call that? Yes, this is the one I have got. We have got sklearn matrix, import from confusion matrix. We are going to do accuracy. True label, the same thing I have taken into account, correct? True label, confusion matrix. Calculate accuracy. How do you calculate? True label, predicted value. This will do it. Accuracy, calculation error rate, precious, recall. And this is my confusion matrix, and this is the result I have got. I hope you got it. Thank you very much.